is something about this place that is good for the human soul.
No matter how good the facilities and the academic program are at a school, it's really the faculty that determine the excellence of the program. Here at the Naval Postgraduate School, we feel that we have an outstanding faculty equal to the best of our engineering schools in this country. As a matter of fact, this is confirmed quite frequently by our departmental visiting committees who come from many of these schools. For example, the requirements for a master's degree throughout the country vary from school to school. Some only require attendance in class. Here at the Naval Postgraduate School, we do insist on a thesis and original research, making this probably one of the most demanding and one of the most complete master's programs in the country. There is quite a tradition behind the Naval Postgraduate School going back to the 19th century. And if we take it that far, back to the days of these sailing ships, our officer trainees received their instruction aboard ship, and they're berthed amidships. For this reason, they're known as midshipmen. And after they finished their course, they'd move aft and join the wardroom officers in the afterguard. But with the advent of steam, it became impossible to continue this aboard ship, and this led to the founding of our Naval Academy in 1845. But beyond this, as time went on, with the increase of steam widely throughout the fleet and the introduction of electricity and sophisticated ordnance, even the Naval Academy wasn't satisfactory for the advanced education needed. For example, if officers were going to design ships, and they were, they'd require advanced education in ship design. Our first graduate students went to the Royal Naval College in London and to other universities in Europe. By the turn of the century, MIT had come into its own, and we were sending students there. Then, in 1909, the Naval Postgraduate School was established on the grounds of the Naval Academy at Annapolis, and it's been growing ever since. By the end of World War II, though, the facilities even there were inadequate, and the school was relocated here to Monterey in 1951. With the technological revolution that is taking place, the program at the Naval Postgraduate School is becoming deeper and more comprehensive every year.
Today, our faculty includes a broad spectrum of recognized scholars in science and engineering.
As delta S approaches 0. And then getting the sum vector signal plus noise.
In the liberal arts, efforts are divided between government and the humanities.
Hitler then was probably right in his estimate of the situation. That is to say, through 1940, he was probably right that the Germans should have attacked the Soviet Union when they actually did. Now, having decided by late 1940 that he was going to attack the Soviet Union, Hitler having decided this, let us now look into some of the implications of this thing. This is going to be war on a giant scale.
Many of our faculty have published textbooks or the results of their own original research. Approximately 3/4 of our civilian teaching faculty are PhDs, and the proportion is increasing. We're very proud that both in the classroom and the laboratory, we have absolutely top-flight men.
This experiment differs a little bit from the more usual type of experimental research in that it represents a sharp break from the previous work that we've been doing. In a sense, it's a long shot. We expect it to work and hope it'll work well, but we have quite a bit to do yet before reaching that goal. If it does succeed, we hope it'll represent a small breakthrough and allow us to explore an unexplored region. I'm Dr. Crittenden of the Physics Department, and this is Lieutenant Wardle, and this work represents part of his activities in connection with his PhD program. I think Lieutenant Wardle should explain the details to you.
We're attempting to generate intense pulses of very high frequency sound, first at 500 megahertz and later at 5 gigahertz or 5,000 megacycles per second. Such sound, of course, is too high in frequency to be heard by the ear, but it's still sound in that it's an elastic vibration in a material. We're using a giant pulse laser, this portion of the apparatus. The output of the laser is split in 2 halves, and the 2 halves are then Doppler shifted by a spinning rotor in this evacuated chamber. The Doppler shifted beams are then fed by mirrors focus through this lens down into the sapphire cube down here, where the nonlinear reaction of the sapphire to the very intense light can be expected to produce sound at the beat frequency between the two light beams. Professor Crittenden conceived this experiment, and we've worked together about a year and a half to design and construct the apparatus. We think we're now to a point where we can expect the predicted theoretical performance very soon. We're now charging the capacitor bank in preparation for firing the laser. Ready to charge?
Right.
Charging. Stand by to fire.
Okay.
3, 2, 1, fire.
Kind of sound powers we'd like to get and are planning for are about 100 million times the present available sound at this frequency range, which is in the vicinity of 5 kilomegacycles or 5 gigahertz. With that sort of power level, there are a number of phenomena that should show up that have never been seen before.
I'm Dr. Vavra from the Aeronautics Department. The students come over here to the Turbo Propulsion Laboratory after they have been working with paper and pencil for a long time. Over here, they are faced with reality. They are making tests with actual machines, and they're asked to compare phenomena which they measure with theoretical results. We may start them out on fairly simple test equipment. This is a cascade test rig, where we can have a visual look at the flow patterns of the fluid particles passing through a blade of a turbine. And then we put them to work on more complicated problems. These students are making a detailed investigation of a turbine wheel which I helped design for NASA. This $100,000 rotor is for the upper stage of the so-called Nova rocket, a real monster. Of course, this rocket is for space explorations after we reach the moon. This upper stage is driven by liquid hydrogen and liquid oxygen, and will develop 1.5 million pound thrust, large enough to put this whole lab into orbit.
Lieutenant Beck will explain what we are doing in this portion of the laboratory.
There are no theoretical means by which the stress distribution in a turbine wheel with a complex shape such as this can be determined. With our hot spin test rig, we are able to measure these stresses at operating conditions in excess of 1800 degrees Fahrenheit and at speeds of 50,000 RPM. These stresses are transmitted electrically through high-speed test rings up over to our control panel, where they are recorded. During this operation, the pit is evacuated to a pressure of 500 microns.
You see, we are working on the problems of the future, and there is no end in sight. We take part in the technological revolution, and we plan to stay right with it.
The Navy of tomorrow is a technological Navy. The number of assignments requiring postgraduate education is on the rise day by day. The naval officer who combines operational experience with a graduate education is more valuable to the Navy and to himself. The officer interested in a postgraduate education can get detailed information from current Bureau of Naval Personnel instructions on the subject, and can indicate his desire for postgraduate education simply by listing it on his officer data card. Selection for the postgraduate school is on the basis of demonstrated professional potential and past academic performance. About half of the officers who enter the postgraduate school each year are surface or submarine types, and the other half are aviators. Postgraduate education, whether in engineering or in management, is here to stay. In these days of rapidly expanding military technology, graduate education is a vital adjunct to operational experience. The Navy must keep pace. If the Navy is to remain a key arm in national defense and a ready instrument of national policy, it will need the best educated minds that America can provide. It will need them. It's going to get them.